you all doing today?
Good.
Good. Lovely to see your beautiful and handsome faces. Nice. Good. So you're all welcome today to AFB UK Next Gen STEM events. And today we're going to be having a STEM event titled Let's Code. And our speaker today is going to be Emmanuel Oni. So I'll just go quickly I'll just go on quickly to give you a little bit of information about AFB UK. So AFB UK is an organization that started in 2007. And here in Scotland, we have a chairman called Dr. Ollie Falayon, who is in charge here. And for AFB UK as well, we have 4 main streams in the Scotland branch. We've got, first and foremost, the Next Gen, which is the forum you're on just now. Now, what the Next Gen program does is to equip young people with knowledge about STEM, and help increase their participation in STEM events. Another stream of AFB UK Scotland that we have is transition, and transition looks at, increasing the number of university graduates that are able to get onto the industry and have gainful employment in STEM related professions. We've also got the real projects, which also offers undergraduate students and people who are already working with the ability to improve on their knowledge base relating to different industrial projects and applications. So you have well-informed experts coming on board to give trainings there at real project sessions. Another stream of AFB that we have here in Scotland is the leadership stream. So what the leadership stream actually does is to equip all workers, all workers basically. So be you employed in any industry, especially STEM-based industries, you're also equipped with different leadership skills, which we carry out through different mentoring programs and leadership trainings. So I will just quickly use this opportunity before Emmanuel comes on board to quickly introduce Emmanuel. So Emmanuel might be a familiar face to you, but I'll just quickly say 1 or 2 things about him. Emmanuel is an electrical engineer based in Edinburgh, and he's very enthusiastic about emerging technologies, and he possesses a keen interest in engineering, design, and problem solving. As an electrical engineer, Emmanuel brings specialist expertise to solutions for buildings, transport infrastructure, energy, water, and waste utilities. Emmanuel has been involved in different stages of engineering, such as studies, concepts, front-end engineering, development, and detailed design of different types of buildings in the last few years. Emmanuel is also a volunteer here in AFB, and is also a STEM ambassador with STEM UK. He has been involved in different community engagements, promoting STEM participation amongst school children, and also acts as a full member of AFB UK, where he organizes different events such as transition events, Next Gen events, and at the transition events, he has been involved in helping final year students get first-hand exposure to how they can transition from university to the workplace. So I'll quickly welcome Emmanuel to come on board. But just as Emmanuel is coming on board, I would just quickly like us to mute our mics, one, and then secondly, if you could just quickly type into the chat where you're joining us from, that would be fantastic. So thanks again and welcome everyone. Emmanuel, you're welcome.
Right, okay, yeah, welcome everyone. Yeah, thanks Serena for that very interesting introduction. You read my resume very well. I wish you can just offer me a job. Right, okay, yeah. Thanks for joining everyone. So today we are just going to be continuing on from where we stopped the last time. Unfortunately, we couldn't do much in the last section due to some technical glitches that we had. So we're just going to continue on from where we left off the last time. And for 2 sections now, we've been talking about C programming. I have given an introduction to what is a program basically is. And we have learned that we have different components of a computer. And one vital component is what we call the software, which is what basically controls the computer. And the process of developing that software is simply what we call coding, or trying to write a code. And we also mentioned that there are different types of codes in terms of the languages, and we saw that there were what we call the high level language, the low level language, also called the machine languages. And we saw a particular one called the C programming language, which we said was a mid-level language, or if you like, actually a low-level language, in the sense that it can directly address our hardware. It can directly manipulate the hardware to do what you want it to do. And so we call it a low-level language in some sense. Sometimes we also want to regard it as a high-level language, in the sense that when you look at the way the code is being written, it's very close to the human language, so you can easily interpret it. So what makes a code either a high level or a low level is how easily the code is being run by the hardware, and how close to the machine language the code is. So C-level language has both properties. So sometimes we just want to call it a mid-level language. But that's not as important as actually writing a C code, which we are going to start to look at in a minute. So I thought I'll give a quick recap of some of the components of a C language for the benefit of those that have not been able to join the previous sections that we've had. So I will quickly share my screen. Right. Can everybody see my screen? Yeah, so I'm just going to do a quick run through. I had a simpler slide, but for some reason, yeah. Yeah, can everybody see this?
Yes.
Perfect, yeah. So I mentioned the last time that your C code, or when you write a code, what you have at the start is what we call a source file. And in your C language, there are different components of a C language. And usually your code starts with what we call a header file and a library file. So I tried to explain what a library file was, and I said it's simply just a pre-written code that helps you do certain function in your code. So this simply controls how your code is being run in your hardware. You don't always have to define them all the time. So they're already pre-written. So what you do is when you're writing your code, you just include them into your code to help you run the function that you want the code to run. And I also said that when you're writing your code, you're setting letters or words that you're going to use. And I said those words are called variables. Just like in a normal human language where you use certain words in English language, in code writing, there are also words or things which we call variables. And these variables are nothing other than just memory spaces that help you hold data. Remember, when you're writing a code, all you are just doing is you're just manipulating a data. And you might ask, what is data? At the base or the core of it, a data is just a 0 and a 1, and that's simply what your computer understands, okay? So usually you have to define what your data types are. And we've gone through a few of those types. And I said there are what we call integer types. I can't find my mouse just now. So there are integer types. There are what we call characters. There are what we call floats, if you remember from the last section we had. And one new one I'm going to be introducing today are what we call strings. A string is different from a character. A character is just a letter, such as A, B, C, D. But when you combine those letters together to form a word, what you have is what we call a string. Okay? What you have is what we call a string. So a string can be something as the word basic. So this is a string because it contains how many characters? 5 characters. So BASIC is a string. Or in this string, you have about 5 characters. So we're going to see how we can write a program where we simply just work on certain words, which we're going to call strings later on. We went on to talk about some operators. We said when you're writing a code, you can either be working on data or you can be manipulating data. Manipulating data in the sense that you can be doing some mathematical operation on the data. So operations such as your addition, subtraction, multiplication, and division, those are all arithmetic operations. Okay, so you can be manipulating data by using the different math operators as well. We went on to talk about certain things called comments in our program. And we said when we are writing a program that one good habit to have is to make sure you put what we call comments in your code. The comments are not important for the code to run because when your processor is running your code, it doesn't use the comments, okay? But the comments are important because once you have written your code and you pass it on to another programmer or another person, you want the person to be able to understand your code. So what the comment helps you do is that they just describe what every line in your code is doing. And again, you don't have to write a comment for every single line in your code, okay? For a portion of a code, which we are going to see later called a block, you can define what that block is going to do. So when I pick your code and I look at the heading, it tells me this, for the next 3 lines or the next 4 lines or this portion of this code, this is what is going to happen or this is what this portion is doing. And how you do that is by what we call commenting, okay? And we went on to look at one simple way you can put something into your code as it is running or take something out of it or present something out of the code when it is running. And we call those things some functions. So we looked at 2 particular functions. If you remember, we looked at the printf function and we looked at the scanf function. Remember, I said the printf function is something that helps you put something on the screen, right? It prints something onto your screen. Then the scanf, what it simply does is that it takes something away from you, which is take something from your keyboard. Okay, so those are some of the 2 functions that we looked at in the last section. What I'm just going to quickly do is give an example. Where my mouse is freezing up. Okay, so what I'm going to quickly do is just show an example of how you combine variables, how you combine comments, and how you combine the print and the scanf function in a code quickly as a summary of what we did in the last 2 sections before we move on to this discussion. So I'm just quickly going to stop sharing now for a minute. Right, and then so again, in the last class, I told you to run your code, you need what we call, who remembers what you need to run a code? After you've written the code, what do you need to run the code? Does anyone remember?
Command prompt.
Sorry, you said?
Command prompt.
A command prompt, okay, that's good. Any other person? Any other person? What do you need to run your code? Does any other person have an idea?
Functions.
Functions. Okay. Well, those are good points. Again, I'll just quickly share my screen. Right. So when you have your code, you've written your code. I told you what you have initially is what we call a source file. Okay. What you have is a source file. I've just turned on my transcription in case you are finding it difficult to hear what I'm saying. Right. So what you have is a source file, which is a .c file. Okay. And once you have your .c file, I told you there are certain other files that we call header files. And these header files are already predefined functions that you don't need to define all the time, but they help you manipulate your data. So they are called .h files. And the process of attaching your .h file to your .c file is what we call a pre-processing function, right? Once you have done that, what you get at the end is what we call an object file. When you attach an object file to a preprocessed file, okay, what you then get is a linked file. And that linked file is then combined with your library files to get what we call an executable file. So when you run your code, what you get at the tail end is a .x file. And this .x file is actually a program that you can then go and install on a computer or install on a hardware. And each time that program is run, everything contained within that code is executed. Okay. And the process of doing all of this is what we call compiling. This middle portion can just be called compiling, but the entire process is actually compiling, all right? And I said you need another software that you call a compiler to compile your code. So that's the word I was looking for. It's called what? A compiler. And I told you, you can install a software in your computer, which is called a C compiler, or there are free ones you can get online. And I gave an address, a web address, codepad.org. If you're on your computer, you can just open a browser and type codepad.org. Can you do that quickly? I'm just going to open my browser and show you that. So every code I'm going to be running, I would like you to always type it into your own compiler online. So that's what you have. Can you see the screen? So the address is codepad.org. Just type codepad.org. Are you there?
Yes, I'm there.
Right, cool. So you hold on a minute and then let's go back to our code. So I'm going to stop sharing again. I'm trying to make this as interactive as it can be so that we all follow, right? So I'm going to share my screen just in a minute. Good. I'm sure everyone can see this new screen now. And I'm going to run a program I have typed here called a scanf program. So if I double click on that, right, I'm sure nobody can see what's happening just now. Right, I think Zoom only allows you share. So right, share. Good. So that's the program I have just opened, right? Can we all see this? Hello, can we all see the screen?
Yes.
Yes.
Perfect. Now this program I am in is called can you see where my mouse is? It's called a per C for Windows. So this is an IDE, an integrated development environment. It's called an IDE because it combines a linker. Remember the slide I showed earlier on that was called the compilation process. It combines a linker, it combines a compiler, and it combines a command prompt executable window, okay, to do all of that. Now on your screen, on your browser, there are portions of that. You see there's a part called outputs. Look at on the browser that I asked you to open. There's a part called outputs. Can you see that part?
What did you say?
On the browser, the computer browser, on your own compiler online, there's a part called output. Can you see that? Can you see that?
I can see output.
Right, okay. And then there's a portion called new paste, right? And then there's a portion called comment. The portion called new paste is your editor, okay? The portion called output is where you are going to output your results, which is your output window. And the comment is where you can just add whatever comment you have. Is that okay?
Yes.
Yes.
Perfect. So let's go back to our program. If you go back to our program, which is what is shown on your screen just now, I'm going to go through the different portions of this code, and I'm going to ask you to type certain things in your own, in that portion where you have new paste, you're going to be typing things there. And when I run my code, you run your own. Hopefully we'll get the same results, okay? Now at the beginning, I have scan f.c, and I said this demonstrates the use of scanf function, okay? This portion of this code is actually called a comment, okay? So if you type backslash, you know what a backslash is, which is that over there. If you type a backslash and you type an asterisk.
Where's the backslash again?
What computer are you using? Are you using a Mac computer or a Windows computer?
I'm using.
Essentially, it should be the same thing. If you check on your keyboard, you see the backslash should be on the same key as your question mark. If you're using a normal Windows.
Oh, yes, I see.
You see that, right? Okay, so if you type that, remember you're typing that into your new paste. So if you type that and then you type an asterisk, that should be on the same key as number 8. Somebody is annotating, right? Okay. Have you done that?
Yes.
Right, perfect. Then type anything you want to type. So you can type my first C program. Type after the asterisk, type my first C program. And then follow that by an asterisk.
Another that.
An asterisk and then a backslash. Perfect. So what you have just done is that you have just created a comment. When your program starts running, okay, that portion of your code, which is that comment, is going to be used for nothing. The processor will not use it, okay? At the point where the processor is doing its linking, it will drop every comment in your program. The comment is just meant for other programmers who would read your program to make sense of what you have written. Is that okay? The next line of my code here is hash include stdio.h. If you could write that as well. Your hash sign followed by the word include. Have you done that?
Yes.
Followed by the word, followed by the symbol, that's an angle bracket. So open angle bracket, followed by the word stdio dot h, then a close angle bracket. Now, that very line you've written, you have just included a standard file. So stdio is a standard header file, and it is standard input output header file. If you write a code and your code is going to include a process where you have to input a number or a word or anything, and then you also have to print something on the screen, your computer naturally does not know what that means. So you have to somehow tell the computer how to carry out that function. And that's the declaration for that process is contained within this function here called the standard input output header file. Okay.
So we're supposed to be doing these codes on CodePad.
Yes.
Okay.
Yes. I think I sent over the installation file for this particular software, which I call the IDE or the compiler software. I'm sure not many of you were able to install it from where I learned. So what you have, the interface you have on CodePad is slightly different from what I have here. Okay, but essentially they should give us the same result in the end. Okay, so let's go on. The next portion of the code is what we call the main function. So you're going to type on the next line, main, M-A-I-N, followed by an open bracket and a closed bracket. And then if you go a line down, you put an open brace. So the open brace is just on the key as the square bracket. Can you see that on your keyboard?
Yes.
So you can put an open brace, right? Then go to the next line and put the word int. Put the word int, I-N-T, and then just give a space and put a letter there. So if your name is James, put a letter J. If your name is Sarah, put a letter S. So choose a letter of your choice, essentially. And then once you have put that letter, it can be capital letter, it can be small letter, whichever one you decide. And once you've done that, you put a semicolon.
I've done that.
So if you can do me a favor, go to the next line, just repeat the same thing with, you put a word float space, put another letter, and then the third line, put the word char, and then type string. I'm going to explain what that last one means, which is the new one we are using today, different from what we used the last time. So you can write char space string, and then that's a different type of brackets, as you can see, is a square bracket. So you write the number 100 there, you close the bracket, and then put a semicolon. So very quickly, what you have done by these three lines is what we call variable one declaration and variable initialization. Sorry, variable declaration is what you have actually done, right? And I said, if you remember from the last time, I said a variable is simply what holds data, right? They just help you create a space in the computer memory. And whatever data you give to them will be stored in that space. That's simply what variables are. And there are different types of them. So now we have seen three types. So there's the integer variable. What's an integer? An integer is what? A whole number, right? An integer is a whole number without a decimal place or whatever. While a float is actually what? A decimal number. So an example of an integer would be the number, for example, 5 or 6 or 20, sorry, or 12, or whatever number, that's an integer number. Okay. A float.
We can put any number.
Don't put any number. I'm just explaining what an integer is. Sorry, Kashisim. Float is a decimal number. So example of a float would be a number such as maybe 5.3, okay, or something like maybe 12.8. So a float, or what we call a floating point number, is a number that has a decimal, okay, that has a decimal essentially. Then the last one we can see here is a character type. Okay, a character type is just a letter. So the letter can be all these 26 alphabets of the English language, right? Now, the interesting thing with a C program is that a C program is case sensitive. Remember when I said you should give a letter here for the integer, and I said use the first letter of your name, and I said you can use a capital letter or a small letter. The trick to that is if you use a small letter, you have to stay consistent. If you use a capital letter, you have to stay consistent. If at the beginning of your program, you have defined a particular integer, x, with a small letter, and later on in your code, don't worry, I'm going to show you an example. In your code, you decide to change that from a small letter to a capital letter to refer to the same thing. Your code is going to return what we call a syntax error. And I said one of the easiest error you can get in your code is what we call a syntax error. So that's what I mean. That's how you spell it, okay? It's called a syntax error. So a syntax error is simply an error that is associated with an incorrect use of either symbols or letters or variable names, okay? Not to waste too much time, the next thing you're going to do on your line of code once you have written all that is, again, you can see the next portion, I've tried to put a comment, okay? Again, remember I said this commenting is just done to help you to help somebody understand your code. So I've said string input. So what I'm simply saying is that beyond this point, the next thing I want to do is to impute a string. And then I've used a function called printf. So the printf simply was print something on your screen. So I've said printf, open the bracket, the instruction is enter a word. Can you do that quickly, please? Printf, then open a bracket. You see, that is a quotation mark, is a double quotation. If you can see that clearly. Can you see that clearly?
Yes, but do we go into a new line?
Yes, you go onto a new line after
Okay.
this very line here. You can choose to leave out this commenting because you already know what the commenting does, right? I've showed you an example up here. So the next thing you do is write printf, open brackets, there's a quotation mark there, write enter one word. Enter one word, and then the next thing you do is put another quotation mark, and then you can close the bracket. So that's a parenthesis. You can close it, and then you put a semicolon after it. Have you done that?
No, not yet.
So where are you?
I've done printf, the open bracket, the quotation mark, and enter.
And enter. So write enter one word. Is that what you did?
Yeah, I just did it right now.
Right, okay. Make sure you had that quotation mark before the close bracket.
Okay.
And then put a semicolon at the end of it. Have you done that?
Yes.
Right. Is every other person following? Right, okay. Then the next thing you do is write the instructions, scanf. If you write everything there on your screen, and if you write everything there on your screen,
your name the way it is, because that's
just the way you can see it, scanf, open bracket, quotation mark. Have you done that?
No, I've done scanf, open bracket, quotation mark. That's all I've done so far.
So can you see the symbol there? So that's what we call, that's a percentage symbol, right? That's a percentage.
Oh, okay.
Yeah, that's a percentage symbol followed by the letter S. That's small letter S. Actually, in mathematics, that's a symbol we call the ampersand symbol. That's how you spell it. Okay, it's called the ampersand symbol, right? So if you put the ampersand symbol, followed by the letter S, followed by the quotation mark, and then put a comma, and then followed by the word string, all small letters. Have you done that?
Yes.
And then close the bracket, and then follow that by a semicolon.
I've done it.
And then you go to the next line under that, put the word return. This is what you're going to do. After that line, don't worry about this green portion, which is a comment. Just go to the next line, put the word return space 0, and then put a semicolon, return 0, put a semicolon, then go down and then put your close braces. That would be the end of the printf and the scanf function. Every other thing underneath that are doing something different. Okay, just for the sake of time, we'll keep it short. So what you have on your screen should be int x, float y, character string, printf, enter one word, scanf, right? You should return what you're written. Sorry, scanf string, return 0. So what's happening here is you're using a printf function, which is going to print an instruction on your screen for you and ask you to enter something. And then the scanf basically going to take what you are entering through your keyboard. So once you print on the screen is enter one word, and then you type the word, okay, on your keyboard, and this scanf function will take whatever you have typed, okay, into your program. Sorry, we just had something else. So what's happening here is we have taken something, but you're going to write again printf so that you see what you have typed is correct. So open bracket, braces, write the word entered is, write percentage s, comma, then write string. So basically, you are going to type in a word and the computer is going to reproduce what you have typed in, okay?
Wait,
Just
so
to be
we're
sure.
supposed to write print f, the word is entered and all that stuff.
Yeah.
Is it underneath that that what's it called?
So underneath the scanf function, type printf. Underneath this function scanf, type printf, the word entered.
Wait, do we need to put any bracket for that?
Sorry, where are you?
I've just written printf.
Yeah, you put an open bracket, yes, followed by a quotation mark, and then the word entered is percentage x, which is percentage string, is the address you are going to look. You're going to look for the word, okay, and the word is contained within that space called string. Remember, I said every variable is a location, so it's looking for a string contained within that space called string. Right? Once you've done that, then on your browser, just go to submit and see what comes up. So have you written printf? The word you entered was, have you written that?
Yes.
Okay.
Okay, I finished now. I'm going to submit.
Right, okay.
Wait, is the language supposed to be C?
Yes.
Okay.
Just a minute. Did you type in that last part, which is the and sign string before the close quotation mark?
Excuse me, Uncle.
Yeah, go ahead.
What did you say we should write again?
Right. So the last line, which is printf, open bracket, then followed by a quotation mark. The word you entered was, there's a percentage sign, X. Are you there?
Print X.
X, yeah. S for Sierra, X, yeah. Don't write the entire word, please. I'm just saying X so that you know what I mean, okay?
X.
So S followed by, you can see that's where you are now. So X followed by a backslash N.
I want to see yours.
Yeah.
Okay, and then you have comma, and then a space, then followed by an and sign. You know the and sign?
No. Oh yeah.
The and sign, like I said, is the ampersand sign, then followed by string, followed by the word string.
Okay.
And then followed by a quotation mark.
What's that?
The quotation mark, you can see it there.
Inverted commas.
It's not comma. If you check on your keyboard, there's a sign on the same key as the number 2.
Yeah.
Yeah, that's the quotation mark, right? I hope that's the one you've been using for quotation mark. And then you close the bracket and then you put your semicolon. I was hoping someone will ask me why we've been putting a semicolon at the end of every line. So the reason why we've been putting a semicolon at the end of every line, remember here we said int x, we added a semicolon, float y, we added a semicolon. So what the semicolon is doing is that as your program is running, remember I said a C program is what we call a procedural program. So it executes the first line and then goes on to execute the second line and the third line, and it goes on like that. There will be times when you write a C program where what you want to come out at the end is probably maybe say at the 6th line, which is here, where we say here, this is where the word you are going to type into your computer will be outputted by your program. This is the final output you want. But the computer executes every line as it goes along. So it will execute a line, give you the result, goes to the next, gives you the result. But you don't want the result of all this yet. You want the final result here. So what the semicolon helps you do is that it helps you hold on to the results that are being produced as you go along. So rather than your program giving you results all the time until you get to the final results, this semicolon helps you delay, if you like, helps you delay those other results until you get to the final result that you want the program to produce. Okay? Does that make sense? Right. So when you click on submit, what do you have?
I sent in my final result.
Is it on the chat?
Yes.
All right, let me check that. Right, so the last line before return 0, right? If you put a space just after the quotation mark, and then you include the and sign string, that's ampersand string. So I'm going to type the last print line for you and share it with everybody. What I mean, copy. I'm going to share that to everyone. So that's how your last line, the print line should, the last print function should look like. That's not the last line of your code, but you see the last print statement. That's what the print statement should look like. So it should be printf, open bracket, quotation mark. The word you entered was %x, \n, close quotation mark, comma, ampersand string, close brackets or close parentheses, then followed by a semicolon. That's the last print statement you should have.
Okay,
Before you
I'll do that right now.
Yeah, so yeah, just edit that last print statement to be that. Before you now have your return 0, semicolon, and then close braces. That simple program takes it takes a word from you, from your keyboard, and it prints out the word on your screen for you. So you can keep changing the word you type in, and it keeps printing every word you type in. It will produce it back to you on your screen. Okay. But the program I have on my own screen is a little bit complex compared to yours. So I'm going to run mine and I'm going to take you through the whole solution for my own program. But that's just to get you typing your own code and see, just giving you a result as well, rather than me just running my code and you don't know what's going on in my own. So your code is just the first portion of my code. Is that okay? Right, cool. So I'm going to go back to my own code now, just to, take you through. So this code, in the first part, asks you to type a word onto your screen and produces the same word you have typed onto your screen. The next part, rather than typing a single word, it's asking you to type many words, which is this portion, which it says print, enter many words. So you can type a statement or a sentence or a message to someone. And as you are typing the message to that person, there's a new function, which is flush standard input output. This is different a bit from the scan in the sense that here you can only take in one word. Here you are going to take in multiple words. So how many of you have seen a paging system before?
I haven't.
You've not seen a pager before. So a pager is a device that you can basically talk and then it scribes what you are saying. For example, if you look on my screen, I'm going to quickly share my screen and tell you an example of what I'm saying. I'm going to stop sharing this screen. So yes, and I'm going to share this one. Can you see my screen now?
Yes.
At the bottom of my screen,
Yes.
that simple program you have just written is what's happening right now. You can see as I'm speaking, everything I'm saying is coming up on the screen. So as I'm speaking, it's taking my word, which is a voice message, where there's another process, that's an encryption program you might have to write to sort of convert the audio into words. So voice recognition and encryption program. But essentially, a portion of that is what's happening on the screen, what you have just written now. For every word I speak, it is displaying it on the screen. Can you see it?
Yes.
So basically, the code you've written can simply do what's happening now. Not everything that is happening, but your code can be a small block within the code that is putting on the screen everything I'm saying. Okay, so it's taking every word and it's printing it. Okay, right. I'm just gonna stop sharing now and then go back to my code again. All right, so that's what's happening within here. So it is flushing onto your output stream every word you put into the keyboard. In this case, I am not putting a word into the keyboard like what I showed you before. That was, everything I said was being transcribed on the screen. So I wasn't typing into the keyboard, but this is using a voice recognition. So everything I say is being displayed on the screen, but it's essentially the same thing. There's a mic in my computer that accepts the words from my mouth. So that's an input. So every time I say a word, it flushes it out to the outstream or the output stream, which is a standard input output stream. Okay, that's exactly what's happening. And that's what your code is doing. And here, what we are trying to do, we are just going to play with some numbers here. So if I'm going to I'm going to build this. If I click on build, it's going to tell me to select what kind of program I'm writing. So I'm going to pick a console program. What a console program means is that it's going to generate a program for you that you can take on to go and install onto a device or install on a hardware or something, okay? So if I okay that, I need to save that first, yes. So that has been built, and it told me building the program scanf.x is done. So you see here, can you see my screen? You see what is generated at the end of building my program is a .x file, and I told you that is an executable file. So you can take this executable file. For example, if I go back to the location of that file, I'll stop that and share my folder for you. You see, I ran that file as a .c file. Can you see it? At the end, it generated a lot of files for me. There's a .ppj file, which is your project, which is the main project. There's a .pss file. This is a PowerPoint presentation file that shows how the code is being run, what we call an algorithm or something. So it shows you the whole routes which the program takes to run. And then there's an interesting one there which we are looking at, which is a .xex file. So if I copy this file, I can do what we call burning. I can burn it into a hardware. And every time I run that code in that hardware, it will do what the code is meant to do. Okay? So I can double click straight from here and it will launch. This is the output of my code. Oh, sorry, you can't see that. I have to stop sharing and share the output again. Right, share. So can you see the small screen? So that's the output of my code. So this is the output of the code, and this is what you're supposed to get in that output portion of your code. So the first line says enter one word. Remember in your code, that was the first instruction that your code contained. So it's saying enter one word. So if I enter the word one, the next line again was, remember we put a semicolon, so it's going to hold that word for us. Then the next one, it says, I think there's something with type. Okay, I think when I was trying to explain to you, I must have typed something that's automatic. Anyway, but it says enter many words. So I'm going to enter, this is a good day. The next thing is going to ask me, enter a number. I'm going to enter any number and say 23. It says the number you have entered is 23. Then it said enter a single character. Any character I enter can be, for example, Q. And it tells me the character you entered is Q. Then it said, please enter 4 characters. I can write the word good. This word good is a string and it contains 4 characters, G-O-O-D. If I enter that, it tells me the characters that you have entered were G-O-O-D, which is the word good. Then the next thing it says is, please enter a decimal number. Remember, a decimal number is a float. And in our program, we defined, remember in our program, we defined a character that was a float, which is Y. So I'm going to enter a decimal number 12. It can be any number. Again, I'm just using random numbers. So it can be any number 12.5. Okay. If I enter that, it tells me the number you have entered was 12.5. Now it added some some other decimal places, 0.0000. And if I go back to my code, you can basically define whether you want the number to be displayed to 1 decimal place or to 2 decimal places, as the case may be. But then that's another thing for us to worry about. So if I click enter now, it exits the program. Now, if I okay that and I just go back to sharing the code, everything in this code was everything that came out. Okay. There were portions where we were asked to enter a single word. There were portions where we were asked to enter a number and the numbers were displayed. There were portions where we were asked to enter a single character. There were portions where we were asked to enter 4 characters. And I think that was, yeah, that was it. And then there was a portion where we were asked to enter a decimal number. And that was the end of our code, okay? So this is the source code that you have written. I said when you build it, it generates what we call, I'll stop and share my file again. When you build that source code, it generates what we call an object code, and the object code is linked to generate what we call an executable code. All right. I know we are almost up with time, but I was going to quickly show you another interesting code with age. So this is an age program. I'm just running an age program. Stop sharing, share again. Right. So this is a new this is another program. This is a program that simply takes your age and compares the age against a certain age and tells you whether you are young or you are old. And it tells you whether you are just a baby or no. So I'm going to quickly run through the code and explain what's happening here. Again, we are defining a new integer int, and we are calling it age. Remember, a variable can be anything. You can name a variable anything. The only thing you need to keep in your mind is that a variable is just a space. Think of it as a box. When you open up a box, right? What do you do with the box? You put things inside the box, right? And boxes come in different sizes. Every box has a size. Similarly, variables have different sizes. If you want to store a large data, you might be looking at storing that. If that data is a number, rather than storing it as an integer, you might want to store it as what we call a double, because a double is 64 bits compared to an integer, which is just a 32 bits, okay? If you want to store a letter, the letter A, you can store it as a character. But if you want to store the word sound, because it contains more than one character, you now have to think about storing it as a string, because a string is a larger bus than a character, okay? That's just that. So we have defined something called age, and then we have defined another thing called a magic age. Now we want that magic age to be 40. So if you are at the age 40, you are said to have a magic age. I don't know what that will mean. It might mean that if you can run a marathon, you can do so many things. So, but let's just assume that age 40 is a magical age, and we are all trying to get to age 40. Good for us if we are below 40, so we can do so many things, okay? Not so good for us if we are already older than 40. So anyways, so the program is asking us, please enter your age. We are going to enter our age. And once we enter our age, our program is going to accept our age. And then it's going to tell us how old we are based on the number we have entered. Then the next thing that is going to happen is that we are going to be using something called an if function. So an if function is simply a function that does comparison. So it takes an argument, a comparison argument, and then makes a decision. So if the age you are going to be entering, so if the age you are entering is less than, yeah, you want to ask a question?
I fell behind a little. Can I press submit? Because this is where I am.
Are you typing out? Are you typing out what's on the screen?
And
Are you typing out what's on the screen just now?
should I be doing that? Because I'm at the part where you told me to press submit, but I'm not sure if I should press submit.
All right. Okay. I see what you mean. We've actually gone past that, but yeah, that's fine. If you press submit, do you get anything from your code? Yes. Okay. So if you press submit, yeah.
It just came up with something random.
Yeah, that thing is actually checking if you're a human or a robot. So before it gives you the result, it needs to do a check. So what does it say? What is asking you to pick what?
So that's all images with crosswalks.
So you check each of those pictures and see which one is what is asking you to pick. So if you pick all the correct selections and you okay it, that should give you a pass. And once you get a pass, the program will run your code for you. Okay. But if you just make a pause just now and follow what I have on my own screen, and then you can come back to running your code.
Okay.
Is that okay?
I got my results.
So what did you get?
I got 1, 2, 3. I got 1, 2, 3, 4. This is what I got.
I can see a red line on your code. It looks to me like there's an error in your code. So what's coming out are just numbers, right?
Yeah.
So that's actually an error because it goes to memory and it can't find a recognizable result. And that's why it's printing out those numbers for you.
I got one error.
Yeah, okay.
I'm not sure what I should do now.
If you take out the first two lines, the last printf line and the last scanf line, sorry, no, the last printf line, if you take that off, and the last scanf line, if you take those two lines off and submit again, it should print out something on your screen.
Okay. So I should take away this line.
The last printf and the last scanf. And every other thing should stay.
I've still got error.
You're still getting errors. So what do you have in your code now? So you have the variable declarations, which are your int, float, and your character, right?
Yeah.
And then the next line after that was what? A print statement that says print enter one word, right?
Printf enter one word.
Yeah, printf enter one word. And then is there a semicolon after the close bracket?
Yes.
Okay. Can you just maybe type your code and put in the chat? Let me see. I think that's easier.
Okay.
Setting, have you typed in your, sorry, have you typed in your code?
I'm typing it in now. I'm almost done.
You can just copy and then paste onto the chats. Do you know how to do that?
It's because I'm using two different devices.
Oh, right, I see. Oh, okay, okay. You know what? While you're typing, I'll come back to your comments and then I'll respond. Okay, is that okay?
Okay.
Yeah, just keep on typing. I'll come back to that. So back to my screen. So this code is simply going to take a number from you, presumably your age, and then it's going to tell you how old you are. And then we are going to define a magical age that we're going to call 40. And what this program is going to do is going to check your age against that magical age. And it's going to decide whether you are very young or you are very old. And it's going to tell you how, if you are very young, it's going to tell you how many years younger you are to that magical age. Or alternatively, how much older you are to that magical age. And that's what this if statement does in a function. So if is just comparing two arguments. So it's saying if your age is greater than a magical age, then it should print that you are very old. And then tell you you are a given number of years older than the magical age, okay? Alternatively, if your age is less than the magical age. Hi, Rena.
Hi, Emmanuel. We are sort of running behind schedule now.
Yes, I'm just going to run through this code and then that should, yeah, should be done in. Thanks for that. Is that okay? Is everybody happy to go through this for the next 5 minutes?
Yes.
All right, okay. I'll be quick. So essentially, I just wanted to use this code to explain the fact that sometimes you have to make a decision in your code. Remember, if you remember what I said about a component of the computer called the arithmetic and logic unit of the computer, which is two parts in a microprocessor, you are either doing an arithmetic operation, which is adding or subtracting, or you are trying to make a logical decision, giving a set of arguments, all right? And this code is doing everything. There's a part where you are doing an arithmetic operation. For example, it's subtracting the magical age from your age to decide how older than the magical age you are. And here it's making a decision. So if statements are conditional statements. So if your age is greater than a given age, it's going to tell you are older. If you are younger, it tells you are younger, okay? And if your age is 1, it's going to tell you congratulations for making it through your first year, okay? So this is just to explain that sometimes your program might be making decisions, or what we call conditional decisions, given a set of arguments, or other times it can just be doing a simple mathematical operation, okay? I'm just going to quickly build this. That's done. And if I run that, right, okay. Because I'm running it within the same program, it's running the same. Okay, so if I view, no, it's still running it as the previous program. I'm going to stop sharing. That should be, oh, finally. Right, okay, that worked. Right, I don't know what was happening. Yeah, sometimes it can be quite temperamental. So yeah, we built that as okay. So it has generated our executable file for us. And if I run that, that's launched the final window for us. You can't see that because I have to stop sharing and then share the final window. Zoom is quite annoying on that. So yeah, so can you see this final window now? It's saying enter your age. So we are going to enter random numbers and say I'm going to say my age is 23. Remember, there's a magical age that we decided was 40. So if I hit enter, it's going to tell me you are 23 years old and you are only young. Do you know why? It's telling me I'm only young because we defined a magical age as 40, and my age is 23, which is what's younger than 40. So it's telling me I'm young because that was the if statement decision that we wanted it to do. Then it said your age is nothing special, sorry. If I hit enter again, it's going to say I can continue running the same program. Just as an example, I'm going to rerun the program again, and I'm going to enter a different number, and then you're going to see how that is different from what we did previously. Now this time around, can you see the new screen? This time around, I'm going to enter an age older than 40. So for example, I'm going to say 89. It's going to tell me you are 89 years old and you are very old. Obviously, 89 is larger than 40. And it's saying that you are 49 years older than 40. Your age is nothing special, sorry. Then the third case, remember it was 3 conditional case. So the third case would be when we are 1 year old. We'll see what the program is going to tell us. So I'm just going to run that again for the 3rd time. And I'm going to share my screen. Now this time around, we are going to try an age, which is exactly 1. And when we hit enter, it's telling us you are 1 year old and you are only young. Congratulations on making it through. Oh, sorry, that was supposed to be true. Congratulations for making it through your first year. I wonder if we put exactly 40, if we are exactly the magical age, what will happen? So that would just be the last case we are going to try. I'm going to run the program for the 4th time, and let's see if we are exactly the magical age. Now, let's assume I'm exactly the magical age 40. I don't know what's going to happen. It's going to tell me you are 40 years old and you are the special age. Life begins at 40. All right, that's the end of the program. Any question?
No.
Right, okay. So I think this just demonstrates that you can write a program to do mathematical equation, like the assignment I gave the last time, where I asked you to solve an equation, writing a C program to solve an equation. You can write a C program to make decisions, give it instructions. You can, see, the large scale of this is, for example, you are driving for automobile cruise control and your car comes close to another car. There are hardware that measures the distance between your car and the next car. Some devices called proximity sensors. You can have a C program running within your automatic cruise control that keep checking that distance. If that distance is less than a already predefined distance, let's say the predefined distance is, say, for example, 2 meters. Whenever your car gets at a distance less than 2 meters, it doesn't do anything. If it gets at a distance exactly 2 meters, it gives you a warning and say you are within a preset value. If you go beyond 2 meters, say for example 1 meter, your car can automatically come to a halt. Okay, so you can write a C program using a conditional if statement to simply do that operation within your hardware. All right, that's just a practical example of what that portion of the code can do in real life devices. So anyways, I think I will stop there for now.
Thank you, Emmanuel, for that very, informative session.
I was meant to explain something to Setting on our code. Okay. I don't know if she's still on. Did she manage to type it?
Setting, are you still there?
No, she didn't type it. I'm just checking through the chat. I can't see.
Okay, Setting is there, but her mic is muted.
Muted. Okay.
Yes.
So the codes I've run today, I'm going to send it over to everyone, and then you can just open the code. If you want to open the code, open the .c file. Open it with either your notepad or your Word. You can open in your notepad. You know the application on your computer called Notepad.
Yes.
Or your Word. Any text editing program can open it. So once you open it, copy it and paste it onto that website and submit it. Hopefully it should give you the same result. Don't change anything in the code so that you don't start getting errors. So if you paste it onto that website, it should hopefully give you the results. I would hope. All right.
Thanks, Emmanuel.
Yeah. Sorry, I've eaten a lot into the time again today.
No, it's fine. Thank you very much. I hope you all had a good time. Just want to ask anybody, do you have any particular questions you want to ask Emmanuel just before we conclude? I can see some of you.
And I think just before the question, can I ask everybody to check out this website? It's called Khan Academy. So you can go on here and, so yeah, it's khanacademy.org, sorry, not .com, .org. Oh, sorry, I typed Akan, sorry. Take out the first letter A, it's khanacademy.org. If you go on there, just type C program, you're going to see a lot of example codes you can play with. And I'm going to share some sample codes I've also written, very simple codes, for example, calculating the average of 3 numbers, for summing up numbers, for solving quadratic equation, simple codes. I'm going to send all of them through Rena. When you open it, look through those codes. You can tweak it as much as you like, changing variables and just playing around with it and see what results you get. Sorry, Mo, you can go on now.
No worries. Thank you very much. Appreciate all of you for tuning in and hope you had a good time. Just want to remind you of our next events. So next week, we'll be having something called Transition University. So if you're transitioning to university, if you're just finished your exams and you're looking forward to going to university, we'll be having an event and just telling you a little bit about what university is, what you should expect, and just some tips and skills you need to build up. Following that, in September, we're excited because we have 2 people. On the 5th of September, we have Uche, who would be giving a talk on a life of an engineer. We also have Araz, who will be giving a talk 2 weeks following that, and he'll be presenting on a simulation to illustrate the movement of the moon around the sun. So that's going to be exciting, and I'm looking forward to it as well. So for the next week's event, please register on Eventbrite. So check your emails, tell your parents, remind them, bug them all around all the time. Tell them that you want to register for the event next week if you are transitioning to university. And if you're not, tell your friends about it and make sure you register for the event on 5th of September, which you'll be seeing in your emails or your parents' emails. Thank you all for coming, and I hope you had a lovely day.